Hi, everybody. First of all, I would like to thank for organizing this amazing conference series. And this paper is a joint work with my PhD advisor, Matt Jackson from Stanford University. And as the title reveals, today I will talk about the macroeconomic impacts of automation. And we try to answer how does automation affect income inequality and aggregate welfare. And it depends on various factors. First, how automation interacts with other factors of production. For instance, automation might substitute for a certain type of labor, but can also complement other types of labor and also like other machineries used in the production lines. And there are market reactions to those transformations, which is basically the displaced labor is reallocated to other sectors and industries. And so it depends on the alternative uses of labor. And also the aggregate implications will depend on how productive the displaced labor is elsewhere. And so when we combine all together, we will see general equilibrium effects such as wage adjustments and price adjustments. So in this paper, we introduce a model in which automation substitutes for some types of labor and complements some others. And this is the first line of the model. And the second part is that there's a key observation. Automation is part of the supply network, and it is used as an input in other parts of the economy, and which is produced in one part of the economy. So existing production network models only consider the complementarity of inputs. And in this paper, different than the existing literature, we use the substitutability of some inputs, and which changes the conclusions dramatically. So in a multi-sector model, market reactions and overall implications depend on the alternative uses of labor and GE effects. So in short, in this paper, production networks meet substitutability of inputs that meet general equilibrium effects. So our contribution is as follows. We show that automation that substitutes for labor can lead to slower productivity growth, increased inequality, and changes in the production network. And welfare gains from automation, and how quick the automation happens, that I will talk about the transition to automation, will depend on how productive the displaced labor in its alternative uses. And we also show that technological advances that do not propagate only downstream, which is a general insight from the production networks model. When a technology improves, then it reduces the cost, and it reduces the prices of the customer sectors, and then there's a supply chain reaction. But we show that it propagates in all directions, including upstream and also to the unrelated sectors via the wage effects. So here's the related literature, and there's a growing literature on macroeconomic consequences of interconnectedness and production networks, and a growing literature by many authors here on labor substituting technologies and automation. So our paper links these two literatures. Okay, so I will give you the N-sector model first, and then simplify it to a 3-sector model, and then come back to the N-sector model implications if time permits. So we consider perfectly competitive economy, which consists of N sectors, and there's a representative firm in each sector. So I will use firm and sectors interchangeably. So a firm I has this production function. So it uses labor and some intermediate goods. So this is total production of firm I. And there are two types of labor, which is high-skilled labor that does not have a direct substitute, and low-skilled labor that can be substituted in certain tasks, which can be shown in here. And this is where substitution occurs. And there are also tasks that are not, that low-skilled labor performs, but there is no direct substitute. So this high-skilled and low-skilled labor might be like also taught as like workers working on routine versus non-routine jobs. So this is just a matter of language here. Okay. So in this economy, there are also intermediates in addition to the labor. So there are two main types of intermediate goods. One is the automation inputs. The automation inputs can substitute low-skilled labor. And like software, industrial robots, and other sort of implications. And the other one is the non-automation inputs that are complement to labor. So that, for instance, electricity, raw materials that do not directly substitute for labor. Okay? And so in this general model, there might be like various types of the various different automation and non-automation inputs that a firm can use. Okay, so there are two types of technological changes. One is cost-reducing technological changes, and the other one is the quality-enhancing technological changes. In the end, we show that they have the similar implications. So competitive equilibrium has a standard definition, but due to the substitutability of inputs, the uniqueness of the equilibrium outcomes is not trivial. And we first show that there exists a unique equilibrium set of prices, wages, and quantities, and aggregate output. Okay, now I will introduce you a simplified case, a three-sector model. And here are the production processes. So there is an automation sector, there is a resource sector, and there's a final goods sector. Automation sector's goods will be used in final goods sector if they're productive enough and replace low-skilled labor, basically. But resource sector's goods that are used in final goods sector will complement all other goods, like the low-skilled labor, high-skilled labor, and the product in the automatable task. Okay. And here's the production processes. So basically, there's a potential flow from the automation sector to final goods sector, but we will see what will happen at equilibrium. And this is the first result. For the three-sector model, there exist two threshold levels of productivity and three phases. So first phase is that, there is a pre-automation phase where basically the technology accumulates, but is not productive enough yet to displace labor. And there's an automation phase in which the level of automation gradually increases as technology becomes more productive. And there's a post-automation phase where there's no labor used in automatable task. And automation is because more productive than the effective unit of labor. In other words, automation becomes cheaper than the labor, and the firm uses only automation in that automatable task. So this is the picture of the transition. Basically, automation transformed the production processes gradually, even though the substitution is linear, which is the general equilibrium effect that we see. And as the level of productivity of automation sector rises, then firms use more automation goods, and it reaches to full automation after a threshold. Okay, so how wages change? First of all, low-skilled labor wage decreases during this substitution phase, and high-skilled labor wage increases. And the key point there is that the less productive alternative opportunities are for low-skilled labor in other sectors, the greater the decrease in the low-skilled labor wage. So if it is less productive in other areas, the wages will decrease more, and it will slow down basically the automation process. Okay, so eventually, how does income inequality changes? It increases during the automation phase, and it is constant in pre- and post-automation phases. And so the rate of change is basically depends on, as you see, the skill dependencies in the automation sector. So it's a simple model which shows the equation which shows that automation production, whenever it depends less on low skill, the displacement will be slower. Okay, so how does the total consumption change? Then we first introduce the sectoral influence definition. A network influence of a sector is basically equal to the change in total consumption for given change in its productivity. And in response to small improvements in technology, the total consumption changes by this. So in pre-automation phase, the technology accumulates, so it has no impact on consumption. But in automation phase, it has this impact, which again depends on the alternative uses of labor, and so its impact, a key thing is that its impact rises as the productivity improves, so as it becomes more used in the economy. And in the post-automation phase, it reaches to the highest level. So when we compare resource sector and the automation sector's impact, we see that resource sector has a constant impact. On the other hand, automation sector's impact is increasing by productivity through over time. So substitutes versus complements have major differences in the network transmission of technological changes. And okay, so so far the discussion was about the small improvements. Now I would like to a little bit talk about the non-small improvements or discrete changes in technology, and which I will show that it results in attenuation in growth, and it can be seen simply in this graph. So basically, when we consider the resource sector's reliance on low skill, what we see is that if it is more, so it means that the low-skilled labor is more productive in that resource sector. So whenever the low-skilled labor is more productive elsewhere, we see that the percentage change in total consumption is higher after the automation. So the less productive alternative opportunities are for labor, the lower the productivity growth that results from the technological improvement. Why it's important when we think about creation of new jobs that we will talk a lot in this conference, then how the labor is productive in its alternative uses becomes very important for its economic growth implications. Okay, so as a result, our results so far show that the reallocation effect and the rising influence of automation provides explanations for the productivity paradox and economic stagnation, that whenever labor is pushed into production processes where it is less productive, then we have a lower consumption growth. Okay, so next we have this transition dynamics. So basically this transition dynamics show that the automation is not a 0-1 process. So there's this general equilibrium effects we see. It starts from 0 and it increases gradually. And again, these transition dynamics depends on the production processes and alternative use of labor in the economy. So now let me give you some examples about it. For instance, both transition start and transition end technology levels are increasing in the ratio of L over H, because if the L over H ratio is higher, it means that low-skilled labor is relatively cheaper, which then makes automation relatively expensive. So then it should be more productive to basically replace labor. And we also see that both transition start and end technology levels are increasing in high-skilled dependency of the resource sector and final goods sector, which similarly have these wage versus price relations. Okay, so on the other hand, when we consider the skill dependencies in the automation sector, then it's different. So you can imagine skill dependencies in the history that whenever a product is automation products are produced in the economy, then they might hire low-skilled labor, high-skilled labor, and different labor types. But now we see that, for instance, softwares and AI technologies, we mostly see that they are produced by mainly the high-skilled labor. So basically, for the implications of what makes today's automation different, then we should think about what makes today's production processes different than before. And what we see here is that, so different than the other results, the automation sector skill dependencies work quite differently. And here this gap means that how long the transition will take. So if that gap is higher, it means that the transition will take longer. And as the low-skilled dependency of automation sector is lower, so it is much more relying on the high-skilled labor, then this replacements become slower. So which means that this gap increases. Okay, so now I will briefly give you the implications in end sector economy. Basically, there are two things. One, there are indirect effects. So an automation can indirectly caused by productivity gains and increases from other sectors that will affect the automation sector that will eventually cause the automation. And the other thing is there might be multiple automatable tasks, so which are interfered in the production processes. So this is an example of indirect effects. Consider the autonomous car example. So it will replace labor in many production processes, and there's a problem there because self-driving cars use crazy amounts of power, and it's becoming a problem which requires substantial increase in the number of electric power plants. So basically, when we consider the autonomous cars, we should also think about what makes an autonomous car. It is AI technology, it is electricity, it is all different things combined through the supply chains. So basically, improvements in AI and electricity production will affect usefulness of the driverless cars and anything that uses transportation, directly or indirectly. So here is the result for network influences in an end sector economy that I will skip due to time limitations. So last thing that I will show is which sectors influences change after the automation. So given that the automation has this impact on the production networks through supply chains, we have this generalized result for the end sector economy. Following switches to automation in some automatable tasks, network influences of producers of those automation goods and their direct and indirect suppliers increase. So this network influence basically can be measured by well-known donor weights, and it's equal to total sales divided by the GDP. So basically, as automation increases, the total sales of that producers of that automation products and their indirect and direct suppliers increase, whereas it remains unchanged for other sectors. So this illustrates it. When F starts to use automation with A1, then it increases the influence of not only A1 but M1 and N2. So this is the last thing about the multiple automatable tasks. And what I show here is that an automation slows down the next automation. Why it happens? Because when an automation occurs, it suppresses the wages down. Then the next automation should be more productive in order to replace labor. So when we think about this multiple automatable tasks and products, then we have this general equilibrium effects, which basically enhance our understanding how automation will impact the economy. So to conclude, automation decisions and their welfare and inequality consequences depend on obviously technological advances, but also the alternative use of labor and how the labor is productive in other processes, and also the interconnectedness through the supply network where as automation occurs, this interconnectedness increases and the production network becomes denser. So, and our results offer explanations for productivity paradox and economic stagnation by showing that it results in some cases slower productivity growth, and also it increases inequality and interconnectedness. Thank you very much.